Okay, this is for algebra, and this is Unit 2, Lesson 3, and we're going to be looking at functions, and we're going to determine if it's linear versus nonlinear. And so there's going to be different ways we can look at this. It's either going to be in an equation form, a graph form, or a table. So I want to let you know right now we're going to change a few things because you don't know just yet about slope-intercept form. So I'm going to change this, and I'm going to just say in a linear equation, when you have an exponent of 1. So a linear equation, not in two variables just yet, a linear equation with an exponent of 1. Which that means something like this. Like, let's say y equals 3x plus 2. The exponent with the x, if there's no exponent showing, it actually has a 1 there. So this is an example that's not not linear. Would be like y equals 3x squared plus 2. So that squared would make it not linear. Nonlinear, and then I should put nonlinear. Another way is if the x is in the denominator. So this is nonlinear. So this would be nonlinear if it was like y over 3 with the x in the denominator. That's nonlinear. But if the x is in the numerator, that would be linear. Now I know this is a little tough right now because we haven't worked with exponents yet. So I just wanted to share that with you at this point, but I'm not going to be really focusing on the equation yet, determine if it's linear or nonlinear, because we need to do some more work with that. But a linear function. So a linear, in order to be linear, in order to be a linear function, first of all, it has to be linear, which has to be forming a line, and a function, just think about this, it cannot repeat the x-axis. So the line, a linear function, to be linear and a function has to be a straight line. So that would be a linear function. This would be a linear function. This would be a linear function, horizontal, but not this. This is nonlinear because in order to draw a line straight up and down on a graph, what values are repeating? The x values are repeating. So a linear function, it's a function whose graph is non-vertical. It's a non-vertical line and has a constant rate of change, which makes the whole thing a line anyway. So this is a function whose graph is a non-vertical. Sorry, I should have wrote non-vertical together. Make sure you don't drop that. Non-vertical line and has a constant rate of change. And we're going to talk about that down here at the table. So a nonlinear function does not have a constant rate of change. It does not have a constant rate of change. Okay. And so basically the graph of it is not a line. So the graph is not a line. So we're going to look here at these graphs. Does the graph represent a linear or nonlinear function? Example, first of all, this is a function. Remember our vertical line test. This is nonlinear. Okay, so this is nonlinear because it's not a constant rate of change. It starts going this way and then goes back up. This one is linear. Basically, it looks like a straight line. So yes, this is linear. Okay. Now, from a table, we want to look to see a constant rate of change. So the way to do this, and I know in 7th grade you guys worked on proportions and finding the, I think you guys called it with your K, your rate of constant proportionality. So remember how you guys had, I think it was probably y equals kx, and that was your constant at proportionality. Well, remember, to do that, you want to look at the constant rate. So the x's, those are going up by 3. They're adding 3 each time. And then 36 to 30, ooh, that's subtracting 6. That's subtracting 6. That's subtracting 6. And we talk about the change of y over the change of x. Now, if you don't know these symbols, we're going to be talking about this when we get to slope. And this is technically what it's doing. It's a change. This is going up by 3. This is going down by 6. So that's a constant rate of change. Okay, so that's going to represent a linear function. When we talk about slope, we'll find negative 6 divided by 3. We'll actually find the slope. So now this one, let's look at this. This is going up by 2. This is going up by 2. This is going up by 2. So that's going up the same. But check this out. 2 to 9, that is going up by 7. 9 to 20, that's going up what, by 11? That's going up by 15. Okay, even though there's a pattern, it looks like it's going up by 4 here. This is non-linear. If it's not going up by the same rate each time, it's not a constant rate of change. So this is non-linear. Oops. Okay, so that was constant, that was constant, this was constant, but this was not. So that's non-linear. That's how you want to tell from a table. Okay, so this is just giving you more practice. Well, is this a constant rate of change? Yes. So this is linear. Then this one, be careful. I know people are like, oh, it looks like 2 straight lines. But what's happening though, it's going down and then going back up. So it changes direction. So this is non-linear. I keep doing that. All right, now from a table. Again, from a table, you want a constant rate of change. What's happening to the x values? Well, this is going up by 1, by 1, by 1. This is going up by 2, up by 2, up by 2. So this is linear because the x's have a constant rate of change, and the y's, they're going up by the same amount. Okay, x is here, that's going up by 1, going up by 1, going up by 1. Okay, careful here. This is going down by 8, by 4. Oh, it looks like it's dividing by 2. It is, so it's dividing by 2, but here's the deal. To be linear, it has to either add or subtract, not multiplying or dividing. Okay, that's actually going to be something else. So for the linear function or nonlinear function, we want to look at adding, subtracting, not dividing or multiplying. So this is going to be non-linear. Okay, now let's look at these next ones with the equations. I'm going to change just a few things because I'm trying to get something down here real quick. I just want to make sure. Good. So a linear function must be able to be written in this format. Now, this is the format that we don't know yet. We've kind of worked with a literal equation, but I'm going to go back to that here in a second. So I'm going to skip this question here. But we also want to make sure that the x does not have an exponent besides 1, or it's not in the exponent spot. So this, for example, this is non-linear. Gosh, I cannot write. So this is non-linear, but this is a focus. We will work on this. We will work on this concept. Okay, because I know this is going to be harder unless you really visualize it and then you put it into calculator, we can see it. Okay, the x is the denominator. No denominator. We do not want the x in the denominator. So this is non-linear. Then this one, well, if we distribute that 6 to both terms, we get 6x minus 6. So the x, there's the exponent of 1. There's no exponent showing. So this would be linear. It's not in the denominator, and it's not used as an exponent, so that's good. Okay, now watch this one. There's an exponent with that x, okay? So exponent of 2, so it's greater, it's just not 1. So this is non-linear. I know this seems very abstract right now, and we'll work with more of this, but I just wanted to kind of touch base with you on those 4 different things. You don't want the x to be in the exponent. You don't want the x to be in the denominator. Now this is okay because the x just has a exponent of 1 because it's there, and you don't want to have any other exponent besides 1 to be linear. Okay, that is it for 2-3, linear versus nonlinear. We will do some more practice, so check the assignment for that.